Section 8.3, Addition and Subtraction of Radical Expressions. Like terms and like radicals. Alright, earlier in the course we discussed this concept of like terms. For example, 12x plus 9x are like terms, and we learned that we could simplify the expression 12x plus 9x through the use of the distributive property. And basically what we said is we could write that as 12 plus 9 times x, which simplifies to 21x. Similarly, if we have these like radicals, 12 times the square root of 2 plus 9 times the square root of 2, we can use a similar process. We'd have 12 plus 9 times the square root of 2, and we can simplify that as 21 times the square root of 2. Like radicals are terms that contain square roots with the same radicand, or in the next course, cube roots with the same radicand. They may be combined to a single radical term. Basically, it's like combining the coefficients with like terms. Alright, so let's look at a couple of these. So if we had 5 times the square root of 6 plus the square root of 6, remember that there's an understood 1 times the square root of 6. So then combining these like radicals, I could write 6 times the square root of 6. 8 times the square root of 21 minus 9 times the square root of 21. That's like 8 minus 9, negative 1 times the square root of 21. Alright, so I'd like for you to try the next two on your own. Alright, if we had the square root of x minus 5 times the square root of x, again, understand that there's a 1 here in front of the square root. So we'd have 1 minus 5, negative 4 by the square root of x. And 2 times the square root of 12 plus 3 times the square root of 12 would be 5 times the square root of 12. But this expression is not completely satisfied. Remember from the previous section that we said it is not completely simplified if there's a perfect square factor remaining under the radical. So if we think of that square root of 12 in its prime factorization, it's 2 times 2 times 3. So we would now have 5 times 2 times the square root of 3. Remembering that when we say that factor pair under the radical, we can bring out a single factor. And so we would have 10 times the square root of 3. And that would be completely simplified. Now, the square root of 20 plus the square root of 45. It's tempting to just add those square roots together and write it as the square root of 65. And we have a rule that allows that for multiplication and division, but not for addition or subtraction. So instead what we want to do is simplify the radicals themselves first and then see if there's a perfect square, if they are like radicals. So I'll use the prime factorization method. Square root of 20 is 2 times 2 times 5. And the square root of 45 is 3 times 3 times 5. And again, I see those pairs. And so I can write that as, then, 2 times the square root of 5 plus 3 times the square root of 5, which simplifies as 5 times the square root of 5. Why don't you try the next two on your own? Square root of 10 minus the square root of 90. Now 10 can only be factored as 2 times 5. So I can't pull anything out there. 90 is 2 times 3 times 3 times 5. Alright, so I've got a pair there that I can pull out one. Alright, so I'm going to go back to 10s here. 2 times 5, that's the square root of 10. Minus 3 times the square root of 10 would be negative 2 times the square root of 10. All right, square root of 75 plus the square root of 300. The square root of 75, 75 would be the square root of 3 times 5 times 5. 300, the square root of, let's see, I think it would be 2 times 2 times 3 times 5 times 5. Again, I hope you remember how to find those prime factorizations on your own. Alright, so let's see, we have a factor pair in the first, and we have two factor pairs in the second. And so that would give us then 5 times the square root of 3 plus 2 times 5 times the square root of 3, or 5 times the square root of 3 plus 10 times the square root of 3, which is 15 times the square root of 3. Alright, so let's look at just a couple more here. So we had 2 times the square root of 99 plus 3 times the square root of 44. Alright, so again, I cannot combine them directly, but maybe there are some perfects, maybe they are like radicals, but it's just not immediately seen. Alright, so I have 2 times 99 is 9 times 9, I'm sorry, 3 times 3 times 11. And then I have minus 3 times, and 44 is 2 times 2 times 11. Alright, and I see those pairs on each radical. So that would give me 2 times 3. And that shouldn't have been a 9 here. That should have been a times 11. So I have 2 times 3 times the square root of 11. Minus 3 times 2 times the square root of 11. And so that's 6 times the square root of 11 minus 6 times the square root of 11. And since those are the same, combining them would give me 0. Alright, why don't you try the other two on your own? Alright, so let's see, we'd have 3, and then we'd have a square root of, now 32 is 2 times 2 times 2 times 2 times 2, and 18 would be the square root of 2 times 3 times 3. So I've got one pair, 2 pairs of 2's in the first radical, and I've got a pair of 3's in the second radical. And so that would give me 3 times 2 times 2 times the square root of 2. Plus 3 times the square root of 2. So 3 times 2 is 6 times 2 is 12. 12 times the square root of 2 plus 3 times the square root of 2 is 15 times the square root of 2. And for the last one, I'd have 3 times, now 50 is 2 times 5 times 5. Don't forget the b. And then I'd have plus 7 times, and 18, we saw that just a moment ago. That's 2 times 3 times 3. And again, don't forget the b. Perfect squares. Let's see, I've got a 5 in the first radical and a 3 in the second radical. So that would give me 3 times 5 times the square root of 2b. Plus 7 times 3 times the square root of 2b, or 15 by the square root of 2b, plus 21 by the square root of 2b, and 15 plus 21 is 36, so 36 times the square root of 2b. Alright, and so we'll end the section with an application. Here we are asked to find the exact area and perimeter of the rectangle, and we're asked to simplify the answers. Alright, so first, I see the square root of 40 and I see the square root of 90, and I can work with them, but I'm going to go ahead and simplify them first. The square root of 40, well, let's see, 40 is 2 times 2 times 2 times 5. So I've got a single perfect square factor here. I've got a 2. And so that would be 2 times the square root of 10. And then square root of 90, using a similar process, that's square root of 2 times 3 times 3 times 5. And I do see a perfect square factor there. And so I'd have 3 times the square root of 10. So I'm going to use those numbers instead. Alright, so first the area. Well, the area, recalling from a previous chapter, is length times width. And so that would be 3 times the square root of 10 multiplied by 2 times the square root of 10. And let's see, rearranging and regrouping. This is all multiplication. That would be 3 times 2 times the square root of 10 times the square root of 10. And that would be 6 by the square root of 100. Well, the square root of 100 is 10, so I have 6 by 10, which is 60. And we would have square feet on that. So 60 square feet is the area. Perimeter, recall, is twice the length plus twice the width, or just add up all the sides. And so that would be 2 times 3 square root of 10 plus 2 times 2 square root of 10, which would be 6 times the square root of 10 plus 4 times the square root of 10, which simplifies as 6 plus 4, 10 times the square root of 10, and the units on that would be feet.